Welcome to the presentation on derivatives. I think you're going to find that this is when math starts to become a lot more fun than it was just a few topics ago. Well, let's get started with what a derivative is. I know it sounds very complicated. Well, in general, if I have a straight line, let me see if I can draw a straight line. I had a straight line. That's my coordinate axes, which aren't straight. Let's see. This is a straight line. When I have a straight line like that, and I ask you to find the slope, I think you already know how to do this. It's just the change in y divided by the change of x. If I wanted to find the slope, really, I mean, the slope is the same because it is a straight line. The slope is the same across the whole line. But if I wanted to, say, find the slope at any point in this line, what I would do is I would pick a point, x. Right? So I'd pick this point. We'd pick a different color. I'd take this point. I'd pick this point. Pretty arbitrary. I could pick any 2 points, and I would figure out what the change in y is. This is the change in y. Delta y. That's just another way of saying change in y. And this is the change in x, right? Delta x. And we figured out that the slope is defined really as change in y. Change in y divided by change in x. X, and another way of saying that is delta, that's that triangle, delta y divided by delta x. Very straightforward. Now what happens though if we're not dealing with a straight line? Let me see if I have space to draw that. Another coordinate axes. Still pretty messy, but I think you'll get the point. Let's say instead of just a regular line like this, this follows the standard y equals mx plus b. Let's just say I had the curve y equals x squared. Let me draw it in different color. So y equals x squared looks something like this. It's a curve. You're probably pretty familiar with it by now. And what I'm going to ask you is, what is the slope of this curve? And think about that. What does it mean to take the slope of a curve now? Well, in this line, the slope was the same throughout the whole line. But if you look at this curve, doesn't the slope change, right? Here it's almost flat, and then it gets steeper, 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 until it gets pretty steep. And if you go really far, it gets extremely steep. So you probably say, well, how do you figure out the slope of a curve whose slope keeps changing? Well, there is no slope for the entire curve. For a line, there is a slope for the entire line, right? Because the slope never changes. But what we could try to do is figure out what the slope is at a given point. And the slope at a given point